Hi, I'm Shivanand from Biome Environmental Trust. So today we will see how to do a filter borewell, the entire process of drilling a filter borewell. First, a fit of 4 feet by 4 feet by 6 feet of around 2 to 3 kl will be dug to make arrangement of water supply for drilling the filter borewell. So next, the filter borewell stand will be set up. You can see here a diesel engine will be there, then a pump for pumping the water will be there, and then the stand with this is the main rod which will be used for drilling. To the main rod, a drilling shaft of 1.5 feet diameter by 2 feet depth will be fixed to the main shaft. 3 pipes will be seen. You can see the 3 pipes. So one pipe will be used to pump the water from the pit to the drilling drilling machine, and then to the drilling bit, and the third pipe is a return valve taking the water from the hole where the borewell is dug back to the pit. The same water will be circulated throughout the drilling process. The water from the pit will help to do the drilling, and then again the return water will go back to the pit, and it will be circulated throughout the process. Only rarely they might be required to fill the pit with the water again. After making all this arrangement, the drilling process will start. In between the main rod and the drilling shaft, a 3 feet rod will be fixed, and through that the drilling will continue. Once one 3 feet rod goes inside, so then a new rod will be fixed. For the 3 feet rod to go inside, it may take around couple of minutes, and if the soil is hard, it may take around 15 to 30 minutes also, or more than that, depending on the type of the soil. The 3 feet rods will be added one after another, and the drilling will be continued till they reach depth of around 50 to 60 feet. These filter borewell vendors have kept 20 rods of 3 feet. So after reaching 60 feet, so they won't be able to drill with the same rods. So what they will do is they will remove all the 3 feet rod, and they will add extension rod of 6 feet length. For about 10 rods they will add, and then again on top of that they will start fixing the 3 feet drilling rod and start going further down. Adding rod like this, they keep on extending the drilling till they hit the hard rock or hard soil when they can't drill any further. So this can go up to 60 feet or 100 feet depending on the area and the type of soil. During the drilling process, when we encounter sandy soil, there is a chance of wall collapsing and drilling becomes difficult. So at that time they will add betonite clay, so which will hold the walls intact in place and will help to continue the drilling. Once the drilling is completed, the next stage will be putting the casing pipe inside the hole. So the casing pipe will be bought in a plumbing shop, and slits will be made in the casing pipe to enable the water from the shallow aquifer to enter into the borewell. Each PVC casing pipe will be around 20 feet length, and a slit of 5 cm height and 1 or 2 mm width will be made. In one diameter, 3 slits next to each other will be made at 3 to 4 places, and this will be continued, repeated at the after gap of 3 feet. So around 7 places it will be made in the 20 feet pipe, and totally there will be around 20 to 24 slits in each pipe. The first casing pipe, which is going down from the ground level, it will not have any slits. So that to prevent more silt entering into the well or to prevent any surface water or the drainage water entering into the borewell. If the depth of the borewell is 100 feet, 5 casing pipe will be bought, and in the first casing pipe there will be no slit. The casing pipe will be connected to each other through a gum, and it will be inserted from top of the borewell into the borewell. The borewell width is 1.5 feet and the casing pipe is 7 inch in diameter. So around the casing pipe 20 mm jelly will be filled right from the bottom to the top of the borewell. So once the casing pipe is inserted and jelly packing is done, so there will be lot of muddy water in the borewell. So that will be pumped out with the help of an air compressor by pumping in the air and taking out and pumping out the water. This process will continue for 2 to 3 days till clear water starts coming out from the borewell. Once clear water starts coming out from the borewell, then we can put a pump in the borewell, make the necessary plumbing arrangement and start using the water for the intended use for which the borewell was dug.
ಸರ್ ನಮ್ಮ ಹೆಸರಿಂದ ಈಶ್ವರಪ್ಪಂದ. ನಾವು ಮೂಲ ಬಂದು ತಮಿಳ್ನಾಡು ಸರ್ ನಮ್ಮದು. ನಾವು ಇಲ್ಲಿ ಇರೋದು ಬಂದು ದೇವನಹಳ್ಳಿ 28 ವರ್ಷದಿಂದ ಇಲ್ಲಿ ಕೆಲಸ ಮಾಡ್ಕೊಂಡು ಇಲ್ಲಿದ್ದೀವಿ ಸರ್. ನಾವು ಇಲ್ಲಿ ಫಿಲ್ಟ್ರ್ ಬೋರ್ ಕೆಲಸ ಮಾಡ್ತಾ ಇದ್ದೀವಿ ಸರ್. ಫಿಲ್ಟ್ರ್ ಬೋರ್ ಅಂದರೆ ಮಣ್ಣಾಗೆ ನೀರು ತೆಗೆಯೋದು ಸರ್. ಮಣ್ಣಾಗೆ ಫಿಲ್ಟ್ರ್ ಮಾಡಿ ನೀರು ತೆಗಿತೀವಿ ಸರ್. ಇಲ್ಲಿ ಬೇಕಾದ ಟೂಲ್ಸ್ ಬರೋ ಕೊಯಂಬತ್ತೂರಿಂದ ತರಿಸ್ತಾ ಇದ್ದೀವಿ ಸರ್. ದೇವನಹಳ್ಳಿಯಾಗ ಮಾಡಿದ್ದೀರಿ ಫಿಲ್ಟ್ರ್ ಬೋರು, ಎಗ್ಬಾಲ ಮಾಡಿದ್ದೀರಿ, ಇಲಂಕ ಮಾಡಿದ್ದೀರಿ, ಸಾದಲಿ ಮಾಡಿದ್ದೀರಿ, ತುಮಕೂರು ಮಾಡಿದ್ದೀರಿ, ಈ ಸುತ್ತ ಏರಿಯೆಲ್ಲ ನಾವು ಮಾಡಿದ್ದೀವಿ ಸರ್. ಒಂದು 1000 ಓಲು ಇರ್ಬೋದು, 1000 ಮೇಲೆ ಮಾಡಿದ್ದೀವಿ ಸರ್. ಇವರು ನನ್ನ ಮಗ ದೊಡ್ಡ ಮಗ ನಡಿ ರಂಜಿತ್, ಅವ್ರು ನನ್ನ ಮಗ ಚಿಕ್ಕ ಮಗ ಅಂದ್ರೆ ಪಾಂಡಿ ಅಂತ. ಇವ್ರು ನನ್ನ ಜೊತೆಗೆ ಒಂದು 3 ವರ್ಷದಿಂದ ಕೆಲಸ ಮಾಡ್ತಾವ್ರೆ ಸರ್. ನಮ್ಮದು ಇದೇ ಜೀವನ ಸರ್. ನಮ್ಮದು ಈ ಕೆಲಸದಿಂದ ನಮ್ಮ ಮಕ್ಕಳಿಗೆ ಇದೇ ಜೀವನ ನಮ್ಗೆ. ಇದು ಬಿಟ್ಟರೆ ಬೇನೆ ಇಲ್ಲ ಸರ್. ಇದು ಒಂದು ಜಾಗ ಬಂಡೆ ಹೆಂಗೆ ಬರ್ತಂದು ಗೊತ್ತಾಗಲ್ಲ ಸರ್. ಒಂದು 50 ಅಡಿ ಹೋಗ್ಬೋದು, 100 ಅಡಿ ಹೋಗ್ಬೋದು, 200 ಅಡಿ ಹೋಗ್ಬೋದು. ಬಂಡೆವರೆಗೆ ನಮ್ಮ ಕೆಲಸ ಮಾಡ್ಕೊಳ್ಳೋದು ನಮ್ಮ ಜವಾಬ್ದಾರಿ ಸರ್. ಬಂಡೆಗೆ ಹೋಗಿ ನಮ್ಮ ಮಿಷಿನ್ ಸ್ಟಾಪ್ ಆಗ್ಬಿಡ್ತದೆ ಸರ್. ಬಂಡೆಗೆ ಕೆಳಗಡೆ ಇಳಿಯಲ್ಲ ನಮ್ಮದು. ಬಂಡೆ ಎಷ್ಟು ಅಡಿ ಸಿಗ್ತದೋ ಅಷ್ಟು ಅಡಿಗೆ ನಿಂದು ಹೋಗ್ಬಿಡ್ತದೆ ಸರ್. ನೀರು ಬಂದು ಕೇಸಿಂಗ್ ಬಿಟ್ಟು ಜಲ್ಲಿ ಹಾಕಿ ಕಂಬಸ್ ಹೊಡೆದ ಮೇಲೆ ಗೊತ್ತಾಗುತ್ತೆ ಸರ್ ಅಂಡ್ರಾಜ್. ಅದ್ರ ಮೇಲೆ ನೀರು ನಮ್ಮ ಕೈ ಹೇಳೋಕ್ಕಾಗಲ್ಲ ಸರ್. ಅಂಡ್ರಾಜ್ ಹೇಳ್ಬೋದು ಅಷ್ಟೇ. ಏನೋ ಮರಳು ಸ್ವಲ್ಪ ಜಾಸ್ತಿ ಬಂದರೆ ಮರಳಿಗೆ ಒಂದು ಅಂಡ್ರಾಜ್ ನೀರು ಡೆಫಿನೆಟ್ಲಿ ಗೊತ್ತಾಗಬೇಕಂದ್ರೆ ಕೇಸಿಂಗ್ ಬಿಟ್ಟು ಕಂಬರ್ ಸಿಕ್ಕರೇನೆ ಗೊತ್ತಾಗುತ್ತೆ ಸರ್ ನೀರು. ಅಂಡ್ರಾಜ್ 1000 ಮಾಡಿದ್ದೀರಿ ಸರ್ ಹೋದಾಗ. ಅದ್ರಾಗ ಬಂದು 100ಕ್ಕೆ 95% ಪಾಸ್ ಆಗಿದೆ, ಒಂದು 5% ನೀರು ಇಳಿದ್ರೆ ಆಗಿದೆ ಸರ್.
Filter borewells are shallow borewells which tap into shallow unconfined aquifer in the fractured weather zone. It can go up to depth of 60 meters in Bangalore context based on the location. Filter borewells function similar to open wells since it will have slits in the casing pipe which will allow to tap into the shallow aquifer. To identify a filter borewell location, we have to see if there are any open wells, kalyanis or lakes with water, or even other filter borewells also which are yielding water. That will be a good starting point to identify the location for filter borewells. After initial identification of the location, it will be advisable to do some hydrogeological studies also to see like how the water enters into the ground through recharge, how the water flows in the subsurface with the aquifers, and also like how the water interacts with the soil and rock inside the ground. The cost of drilling one filter borewell of around 100 feet depth will be around 1 lakh rupees. And this does not include the cost of the pump and the plumbing connections which need to be done separately. Over a period of time, based on the type of the soil, the filter borewell could require maintenance once in few months or few years. When we find that the pump and the motor is getting blocked due to the silt in the filter borewell, it will require cleaning with the help of an air compressor by pumping in the air and pumping out the water from the filter borewell. Deep borewells draw water from deep confined aquifer, that is the rock layers deep underground, where the water is trapped under pressure in the cracks of the rocks. These aquifers are formed over many years or sometimes even centuries due to the water percolating into the rock. The depth of the deep borewells varies between 500 to 1500 feet in Bangalore based on the location and based on the extraction status from the borewells. Typically, the deep aquifers are overexploited in India, where the areas are dependent on the groundwater. Once we started using the deep borewells, the shallow aquifers are mostly neglected and unutilized in most of the parts. The shallow aquifer can also be recharged faster than the deep aquifers with every rain. So hence it is important to use the water from the shallow aquifer and reduce the usage from the deep aquifer, which is already overexploited. Also, drawing water from the shallow aquifer requires less energy, which will lead to lesser carbon emission, and hence it will help in adapting to the climate change and mitigating the climate change also.